In this video, we are going to be learning how to transform cubic functions. This is the parent graph for a cubic function. Easy to remember because a cube is 3D, so there's a 3 right there. Here's the general form, which will look familiar. The only difference between this and the other ones we've seen is there's a little cube right here, but we still have the A, the H, and the K. So the A, the H, and the K are still the same things. The A is the flip or the vertical stretch. The H moves it left and right, it's the horizontal shift, and the K moves it up and down like a kite. Then we have our parent graph. So let's see what this parent graph, or this basic version of this cubic function, actually looks like. Got my X and Y plane. I'm going to set up a little T table to help me figure out my values for Y equals X cubed. So let's start by plugging in 0, 1, -1, 2, and -2, just our basic numbers we always plug in. So first let's do 0 cubed. Plug 0 in. So if I were to plug in 0, 0 cubed is 0 times 0 times 0. That's 0. So I can plot that point. That is my locator. That is my starting point. We can also think of it that way. And I'll just label it as the locator. That is the locator. All right, 0, 0. So from there, we're going to start plugging in these values. We'll start with 1. So if I were to plug in 1 cubed, 1 times 1 times 1, that's just 1. So we can plot that point too. And now we need to know -1 cubed, so that's -1 times -1 times -1 again. And we can kind of break it down. So -1 times -1 is a +1 times that last -1 turns it back negative. So it's a -1 as the answer. So -1, -1, that's our new point right there. Next we have 2 cubed, 2 times 2 times 2, that is 8. So we have a new point, 2, 8. I'm just going to add some labels here. Last one to plug in is -2 cubed. So that's -2 times -2 times -2. Break this down, we get a +4 times -2, which ends up as -8. So the new point, the last point on our graph, is -2, -8. And here's -8. Plot the point. And if we connect these dots, we can see the cubic function's parent graph, or the most basic version, this S shape. So let's take it back a step and write down the pattern, because this is what we use to graph these whenever we do transformation. So we went to the right by 1 and up by 1. So I'm going to write that pattern down. Right by 1 and up by 1. And then we go right by 2 and up by 8. So right by 2, up by 8. And then when we go to the left, I'll just erase this here. When we go to the left by 1, we went down by 1. So left 1, down 1. And then the last one is we go left by 2, but down by 8. Left 2 and down by 8. Okay, so we've got our pattern. This is like the main takeaway we want to use when we're going to go and graph one of these. So let's do an example with that pattern. So we have y equals x minus 3 cubed plus 1. Let's start out by noticing there's the A, the H, and the K. So let's identify those so we can figure out our transformations here, how this graph is changing. So we'll start first by identifying the A. Well, there's no number in front of the parentheses, so it's going to be 1. So it's just 1. And that just means that there's no change. There's no stretch, no flip, nothing like that. Our H value is 3, and even though there's a minus sign in there, in the parentheses, X is a liar, so it's a +3. And then 1 on the outside is up 1. So the 3 means to go to the right by 3. I'll just draw a little arrow here, right 3. And then the K is 1, it means we're going to go up by 1. So let's start this graph by first just drawing our parent graph. So I'm just going to add this in here real quick. And remember, we like to use the parent graph on our when we're graphing these, because it gives us the general, the basic version of it, and we'll figure out how to graph it from there. So I'm just drawing my parent graph, copying the graph from the last page. So I got my locator, and then I'm just following my pattern to graph it, connecting them here. All right. So again, this is the parent graph. We're going to use this to help us graph this new example. Okay. So this is the parent. And again, that pattern, I'm just going to write it down for future reference. Right by 1, up by 1, left by 1, down by 1, right by 2, up by 8, and left by 2, down by 8. Okay. So now we actually need to take this new graph and write down what is the locator, what's our new starting point. Our new locator is going to come from the H and the K, so it's going to be 3, 1. And again, that comes from the H and the K. 3, 1. All right, so new locator, let's graph it. It's going to be right here. That's our new starting point. And from our new starting point, we're going to follow the pattern. We're going to follow the pattern. That pattern I have written down there. All right, so the pattern says to go right by 1. From our locator, we're supposed to go to the right by 1 and up by 1. So here's our next point. And from the starting point again, we're going to go to the left by 1 and down by 1. So there's the next point. From the starting point, we're going to go right by 2 and up by 8. 6, 7, 8. All right, there's the new point there. And then from our locator, we're going to go left 2 and down by 8. So we're going to land right about here. All right, so new graph. Let's connect the dots. So we have transformed our parent graph by moving it. You can see here, comparing the two, we went to the right by 3 and up by 1. That's how it was transformed, and this is the graph.